Thank you for your introduction and for giving me the opportunity to have a talk here. My name is Shinji Kusumoto, Osaka University, Japan. And the title of my talk is Re-evaluation of estimation study result using ISBSG data using a different data set. Okay. So this presentation is mainly based on this paper. I'm sorry, but the abstract is in English and the text of the paper is in Japanese. So this is the content of today's talk. At first, I'll explain the background of this study and then talk about the research objective of the study and also the three research questions and present the result. Okay. So, background. In empirical software engineering, it's important to conduct replication studies. I call it re-evaluation in this title on the findings of existing research studies. And replication studies are intended to ensure, for example, whether the findings obtained under certain conditions can be replicated under other conditions, or whether different conditions or environment yield different findings. And by integrating the results of the replication studies, it increases the relevance of using the findings of existing research studies. Okay. So the objective of this study is conducting follow-up replication studies on existing study of estimation, where the ISBSG dataset are used in the evaluations. So by changing the repository or dataset used for the evaluation. And in the follow-up studies, if the different findings are obtained, it leads to consideration of causes of different results and additional research. And if the similar findings are obtained, the external validity of existing research results has been enhanced. And here, the external validity is the validity of applying. I'm sorry. Here, the validity of external validity is the validity of applying the conclusion of a scientific study outside the context of that study. Okay. Now, ISBSG dataset, as I'm sure you all already know about it, but I briefly explain it. And it collects software project data from IT companies around the world and provide a wide array of data available for benchmarking. And I checked the website and get there are about 10,000 projects in the development and enhancement repository and about 1,000 applications in its maintenance and support repositories. And the data consists of many attributes for each project. For example, effort, performance, number of developers, size of function pointer, lines of code, and development language, and so on. And the data is provided in the form of a spreadsheet like this, and it's also from ISBSG website. And there are several attributes and development types, language type, and counter approach or something like that. So in this study, we set three research questions to be clarified when conducting a follow-up evaluation. And here, RQ1 and RQ2 correspond to a kind of preparations. And RQ1, how many studies in the past 5 years? That is actually from 2012 to 2017. So it's the result is a little bit old, but I'm sorry. And so how many studies in the past 5 years have used the ISBSG dataset in the evaluation studies? So RQ1 was set to clarify the extent to which the ISBSG data set is used. Although it's considered to have higher external validity than other datasets, I think because it contains many data from multiple companies. And RQ2 is how many studies exist that can be tested and be easy to apply to actual software development project. As for RQ2, we consider that the estimation of the development effort should be highly usable in the actual project. But in reality, there are many research results that are difficult to apply to the actual project. For example, it's necessary to develop estimation tools, or sometimes part of the estimation method of the result are confidential. So RQ was set to clarify the percentage of studies to be easily re-evaluated. So RQ3 is the main question. Are there any differences between the findings from ISBSG dataset and other ones from different datasets? So I showed the result of the 3 research questions. This is the result of RQ1. We surveyed these international conferences and journals, and there are, as a result, there are 83 papers about software estimations, and 22 of them used ISBSG dataset in the evaluation. I think the percentage of using ISBSG dataset is relatively high. And so we could say the ISBSG dataset is a kind of standard data to use in the estimation studies. So this is the results of RQ2. From the 22 papers, it is necessary to select papers that could be used for the follow-up re-evaluation study. And we set several conditions for selection. For example, actual project data used in the evaluation, and so only data that are available to us are used. And accurately describes the information necessary for the evaluation. And also easy to apply in the actual project. So that is the method relatively easy to construct an environment for developing the estimation tools proposed in the papers or a model for actual use. And as a result, we selected these 4 papers. And next, I explain the summary of these studies. And just a summary. So if you want to know the details of this paper, please refer to the original ones. So this is the summary of P1. It the research of effort estimation models based on the conventional regression analysis. And P1 proposes a new method of creating an effort estimation model that takes into account the project manager's prediction of the productivity of target project. Okay. And this figure shows the conventional method to create the effort estimation model based on the regression analysis. And this data set consists of multiple project data from P1 to PM, and they are from the past. And each data consists of several attributes. Here, each has after E means after effort, and then other N attributes. Okay. And using these data, the effort prediction model is obtained by regression analysis. Okay. And when the effort of the target project PK, it has also N attributes. By substituting these attribute values to this model, we can get the predicted effort of the target project. And this is the proposed method in paper P1. And this data set is consists of multi-project data from the past. It's the same, but since we can evaluate the productivity of the past project, so the data is divided into two categories. One is a high productivity data set, and the other is a low productivity data set. And it creates a model for prediction model is created for each data set. And in estimating the effort of the target project, at first, project manager predicts the productivity based on the attribute of the target project. And if the project manager expects the productivity of the target is likely to be high, then he selects the prediction model for high productivity project and estimates the effort. So if the project manager's prediction is correct, the accuracy of the prediction is likely to be high. And in the evaluation, the so-called cross-validation method is used. This evaluation method is also conducted in the paper P2 and P4. And I briefly explained it. The original data is divided into, in this case, I'm sorry, in the evaluation, sorry. So here, this is an example of 5 cross-validation. And the data is divided into 5 pieces, and one of which is test data. And remaining 4 pieces are used as training data to make the prediction model. And so that is 4 pieces are used to create the model, and 1 piece is to test the model. So, and estimated effort is compared to the actual effort of each of test data in this piece, and we get the result. And also apply to these other 4 patterns, and by averaging the results, the estimation accuracy is evaluated. Yes. And proposed method in P1 is evaluated by using the ISBSG dataset release 9. And data is selected by using these selection criteria. Function point standard is IPSJ 4 and data quality rating A or B or something. As a result, 593 project data were selected and used. And this graph shows the result. The horizontal line represents the misclassification rate. And that means the percentage of project managers selecting the wrong model. Okay? And the vertical line represents the average BRE. And here, the BRE represents the relative error of the predicted value from the actual value. So the smaller the value, the better the accuracy. Okay? And in this graph, this blue dot, blue dashed line is the result of a conventional method. Since there is only one model that can be used, so the BRE does not change. On the other hand, this red dashed line is the result of a proposed method. And there is a green line, but please ignore this green line. Okay. So you can see if the correct models are selected in the project manager's prediction, the result achieves a higher accuracy compared to the conventional ones. But naturally, if the project manager selected the incorrect model, the results show lower accuracy. Right? So the findings of P1 is the proposed method is more effective when the project manager is unlikely to make a mistake in predicting the productivity of the target project. And this is a summary of P2. P2 suggests how to handle categorical variables in effort estimation. Here, I want to go into details. As you know, the categorical variable means a variable that generally cannot be measured in numbers or quantities. For example, gender, occupations, and in ISBSG dataset, programming language development platforms are categorical variables. So in creating the regression model, sometimes categorical variables are not used. And in order to use categorical variables as explanatory variables in a regression model, such as dummy variable conversion, etc., is usually used. And this paper P2 compared 4 different estimation models with 5 with different ways of dealing with categorical variables. As the 4 methods are stratification, dummy variables, interaction, and hierarchical linear models. And the details of these 4 methods please refer to the original paper. And using for dataset, ISBSG data is included in dataset. And the result, the most effective method of dealing with the categorical variables is different for dataset. But prediction accuracy will be higher if categorical variables are taken into account in the model. And this is a summary of P3. P3 is about measuring function point. P3 proposes a simple function point estimation model based on the ISBSG dataset. And it created a function point estimate model that uses explanatory variables, only those factors that have the strongest correlation with function point among the 5 base functional components EIQ, EO, ILF, EIF that constitute function point. And in order to evaluate the correlations, it uses ISBSG data release 11 and selected project data by using these selection criteria. Data quality rating, A or B, UFT rating, A or something. And the selection result, P3 uses about 600 project data. And one of the findings is a factor most strongly correlated with function pointers, EI external input, and showing a simple model with EI as explanatory variables. The model is this one, very simple. And last time summary of P4, it deals with the software development duration estimation models. It proposes 2 different models using neural networks and compare the accuracy to the conventional regression model by using ISBSG dataset release 11. And by selecting the project data using these criteria, 49 project data were used. And this table shows the result. MAR and MDAR were used to evaluate the estimation accuracy. MAR is the average of absolute residuals of duration, and MDAR is the median of the absolute residuals. So the smaller MAR and MDAR, the higher the prediction accuracy. So you can see compared to conventional multiple linear regression models, these 2 models using neural networks have a good accuracy compared to linear regressions. So the findings of P4 is both of the 2 estimation models using neural network improve the accuracy over the multiple regression models. Okay. So this table summarizes the result from P1 to P4. P1 and the findings using ISBS dataset. So P1 the probe method is more accurate than the conventional model, and P2 modeled using categorical variables are more accurate. And P3 EI is correlate the most strongly with function point. And P4 neural network models improve accuracy to the regression models. Okay. So RQ3 main question: are there any differences between the findings from ISBS dataset and one from different datasets? So this slide shows the dataset used in the follow-up evaluation studies. First one is the IPA-SEC dataset. IPA, it is used for P1 through to P4. And IPA is the Information Technology Promotion Agency in Japan, and it is an incorporated administrative agency of Japan. And SEC is a software engineering center, one of the department of IPA. And currently the name is changed to IT Knowledge Center on Emerging Tech Trends. And the IPA-SEC dataset include 300 3,541 projects collected from IT companies in Japan. All data from Japanese company, and each of which has 194 attributes. And by signing a contract, we could use the data in spreadsheet format, like ISBSG dataset. And the example attribute effort person was number of developers, size, function point, and line of code, development languages, and so on. So they are similar to ISBSG dataset. And also, I published these software development data white paper, which shows analyzed software development data in the enterprise field for use across software companies as a reference for development project. And the next one is a certain company dataset. It was used in the follow-up study of P3. It includes 98 projects in each of which has 144 attributes. And data from insurance and banking software projects. A certain companies also in Japan. So on the other hand, the ISBSG dataset and IPSJ dataset are collected from more application domains. So we conducted the re-evaluation of P1 to P4 by using mainly ISBSG dataset. And this table shows a summary. For P1, the findings using IPSJ dataset is the same as using ISBSG dataset. P2 is also same as the ISBSG dataset. But on the other hand, P3, IEICE are strongly correlated with function point, and by using a certain company dataset, EO correlate strongly. So the result is slightly different. And also for P4, one of the two neural net models improved accuracy. So this result is also a little bit different. So due to the time and my memory, I only present the result of P1 and P3. So the left graph is the same as the one I presented earlier, result of ISBSG dataset. And this is the result of the follow-up using IPSJ dataset. And so we select the data from IPSJ dataset by using the same selection criteria, and we get 180Q data from IPSJ dataset. And this is a result. And you can see the result shown in both graphs appear to be similar. That means if the project manager's prediction of the productivity of the target project is correct, the result, the accuracy becomes good. Okay? But of course, the details values are slightly different, but the trend seems similar. So if the correct models are selected, the result achieves the higher accuracy but naturally incorrect model is selected, the results show low accuracy. Same in the ISBSG dataset. So the proposed method of P1 is more effective when the PM is unlikely to make a mistake in predicting productivity of target project. So as a result of this re-evaluation, the validity of the result of P1 is enhanced, I think. So next is a follow-up of result of P3. As I explained in P3, IEI correlate most strongly with function point. It's in the Kendall and Spearman's rank correlation coefficient. On the other hand, using IPSJ dataset, the dataset, it includes 122 project data. They are selected by the same selection criteria in P3. In this case, EI correlate most strongly with function point in Kendall's correlation coefficient, and but EQ correlates most strongly with FP function point in Spearman's correlation coefficient. So it's slightly different. And also using a certain company data set that includes 55 project data, they are also selected by the same selection criteria in P3. In this case, EO correlates most strongly with function point both in Kendall and Spearman's rank correlation coefficient. So the result shows that when creating a simple function point estimation model using a base functional component like in P3, it's necessary to select the appropriate elements for each dataset. And to it additional analysis that let's look back at the characteristics of the dataset. ISBSG and IPSJ dataset are collected from various application domains. On the other hand, certain company dataset from only insurance and banking application domain. So we evaluated each repository categorizing by application domain. This is a result. Based on the application domain, in ISBSG dataset, 619 data classified into 5 domains. Each domain has more than 30 pieces of data. So the total of the data is not equal to 619. Maybe this total value is 420. And we have created one domain that combines insurance and banking. Okay. And then evaluate the correlations. You see the result vary depending on the domain. And then we added the result of a certain company dataset. We tried to classify the IPSJ dataset, but gave up because the number of data in each domain become very small. So in this case, the result is the same between ISBSG insurance and banking domain, and certain company dataset. It's also the insurance and banking domains. So it may be a common saying, but from this data, it's better to make some categorization of the data before conducting the some kind of analysis. Oh. So Now I conclude my talk. We have conducted follow-up study re-evaluation on existing studies of estimation, where the ISBSG repositories are used in the evaluation by changing the repository. And as a result, we set 3 research questions, and the each result is RQ1 is there are 22 papers about soft estimations used the ISBS data set in the 5 years. And RQ2, 4 papers are selected for re-evaluation. The RQ3, 2 papers have findings that differed from existing studies, while the other 2 papers are nearly identical findings. But the future works, it's necessary to conduct follow-up studies on other existing software estimation studies, and also to conduct follow-up studies with different data set from ISBSG and IPSJ data set used in this study. So that's all. Thank you. Thank you.